Yeah guys, today is the day we are back in the AC-Powerwall studio, and this is the day when the new inverter will be installed. Everything what's behind these doors, something here and here, needs to come out, and at the end this inverter will just come in there. Should be a fairly straightforward job. So the first thing I want to do is take off this door, because this door will then also remain off. The inverter needs some space to breathe, and it will also just fit right in there. And then I will show you what we need for this install. So yeah, before I am starting to dismantle the good old Powerwall 1, let's look back. How did it actually perform? And which of the components performed well? Where did we have the problems? If you know my channel, you of course already know from other videos what failed most of the time. But yeah, let's just talk about it quickly. Let's start with the DIY controller. You know, this is the controller which is managing all the Powerwall operation. It is getting information from a smart meter here from my main distribution board, and the controller is then deciding what happens inside the Powerwall. It is essentially controlling 4 chargers, 3 inverters. Then it takes a lot of measurements, voltage, amperage. It is running a couple of fans, reading temperature sensors, etc., etc. And this was actually really a joy on this project, because I gained a lot of knowledge about microcontrollers, about coding, etc. So the only one thing here, these small OLED displays, so DIYers will know them. That's the 1-inch display, and yeah, they are not meant to run in this environment, hot and humid. So I have replaced it several times, but it's always just holding up maybe 1 year, and then it's getting dark on it. But everything else works quite perfectly. Initially I was running all these high-powered devices like chargers directly from relays inside the controller, but those small relays are not meant to run these high-powered devices constantly. So what I did then is I have run these solid-state relays from those small relays inside there, and yeah, you can even see on these ones, you see here quite some discolorization. So they are also quite struggling with all those loads. But why is this one kind of discolored from heat and the other one are not? Because here you can see I have a protective cover on it, and here not. And of course this cover is an extra insulation, and it makes the relay hotter than the other ones. But they're still working fine, no problem. But you can get better ones, which can be mounted on a DIN rail, and they have a heat sink built in already. So the next really well working have been the chargers. I have here 2 constant output chargers. This one, albeit, have already an external fan, because the built-in internal like this one failed, and so the charger was reducing its output when it got hot. But nevertheless it still worked perfectly, and with the external fan on it, everything is normal. A very big surprise have been these variable chargers here. I have rebuilt it to work on a digital potentiometer, so they are controlled by the controller and also this worked absolutely flawlessly. You know it, what made quite a lot of issues have been the DC MCBs. They have also struggled with the climate here in Thailand, but since I have replaced them with fuses, no issues there. What was quite a challenge here on the Powerwall was the DC current metering from my battery. So I tried many different ways and sensors, initially with a shunt, until I ended up with my DIY Hall sensor, which is quite hardened against ripple and noise, and only this one gave me reliable current measurements here, and only then I was actually able to implement a quite good column meter feature here into the controller. Last but actually least also in their reliability have been the inverters. You know that already. The soft start worked perfectly. I never had an issue on the DC side of the inverters, but they constantly failed on the AC side, and this is the main reason why I had got the new inverter, why I have to replace all this and make the new version of the Powerwall. Yeah, the only remaining thing here from the Powerwall 1, which now initially I will not touch, are the battery cells, my 96 lithium iron phosphate cells. They were used when I got them, and they are really very beaten up, and yeah, the performance of them, capacity is dropping all the time, so they will be then replaced next. So yeah, goodbye DIY Powerwall 1. Welcome DIY Powerwall version number 2. Yeah, so inside the main distribution board, the only job I have here is to remove all these breakers and protectors, and they will be replaced by a 4-pole main breaker here, which is then just bring our power to the inverter. And then here one of the CTs is already installed, so the other 2 new ones will just come left and right on the big cables there. So this inverter is going to be installed grid parallel right at the entrance of our distribution, and the CTs are taking their values there, energy values, and transferring the information to the inverter, and the inverter can then interact with the grid. Now the power should be completely removed from the Powerwall. We are going to check this, of course, for safety reasons. So neutral phase, and yeah, the power is removed. We can now start working. So as I said, every single piece of equipment will be removed. On this side, this is my conduit going to the main distribution board. All existing cables will come out. The only thing I will keep is the grounding wire. I will have an extra grounding wire which will then ground inverter body. In this second compartment, eventually I will just make a small junction box with 3 outlets, each on one phase, which will be connected to the load output of the inverter. So in in case of a blackout, that I also can use then this battery to supply some electricity to somewhere. I just cannot connect anything real permanent on the load output, because these buildings here, they all just run on one phase, and that it would overload a phase of that inverter anyway. Okay guys, after 3 hours all the compartments are empty. Number one here and here, only battery main cable left and data cable grounding there. I've already installed the main breaker in the main distribution board, just need to pull the other cables then. Yeah, and this is why I said this is a one-way job. Look how much stuff was installed here over the years. This is just cabling, all the breakers, etc. And these were the installed devices. And there on my wall as well, everything full laying around there. So yeah, never ever can this be rebuilt. Whatever comes, this inverter needs to exactly do what it should do in this case here. Yeah, and I got the help from one of our guests. The inverter is hanging on its place. This is how it fits. Quite perfect. The door will not be installed, as I said. This is to keep the air flowing around the inverter. So what I have to do now is get the cables to the main distribution board and then insert it installed at the inverter. This inverter does have, of course, quite a lot of ways to connect, but for us the only thing we will use is this one, the grid input. This is also a breaker, so we have a breaker on both sides, and battery cables. And then what we will use here are some, I have to check which ones are for the CTs, and that's all we need. Yeah, as you know, this is not the final setup. This is just a 25 square millimeter cable here, good enough for the old battery. And yeah, this is still just a proof of concept. I will just connect the fuse holder, and yeah, this will also just be temporary here. Then I want to pre-charge the capacitors with one of my resistors which I had in the Powerwall, and then we can turn on the unit. Good, this is now my 50 ohm resistor from before. I will now touch each of the sides and pre-charge the capacitors. And now just plugging the fuse. And that's it. So, as I said, this will just stay like this. to demonstrate that our case is working. And what I'm going to do now is turning on the inverter and see if this display is starting. And we do have a working inverter. 51.8 volts on the battery. It's showing off-grid, no PV input of course. So let's get some grid connected and then I will do the basic settings, but we will talk about settings in a separate video anyways. The MDB side is finished. We have now our new 4-pole breaker and the 6 square millimeter 5-core cable, which is going to the inverter. So the ground here is coming from the main grounding bar here from the main distribution board. Here you can see our 3 new CTs, L1, L2, L3, and yeah, they will transmit now the data to the inverter. Now we can go to the inverter and connect the grid side there to the grid terminal. So as these cables are soft stranded, we use ferrules. I have grounded the inverter chassis, is here on the back side. So on this side they are called RS and T, which is L1, L2, L3. The brown goes to R, L1, black goes to S, and gray goes to T, and ground. So the last are our CTs, and according to the manual we should use a magnetic ring and loop the cables 4 times through the magnetic ring. They say actually 4 times, I don't have as much wire, so 1 time should be enough. I have marked my pairs here. This is CT number 1. CT number 1 comes in connections 3 and 4 here. They do not tell which one is white, which one is black, but I'll just connect the white first and then the black, and then we just see. When the CT readout is not correct, you just need to flip the wires and that's it. It's already 4 o'clock in the afternoon or 4:30. There should be no export anyway. So we will see right away that there is a false readout. Okay, let's check up close one more time. We have made a battery connection. I have here 3 CTs connected and I have my grid connected. The breaker will stay down now. I will now go and turn on the breaker in the main distribution board. Then we can check if the voltages and phases are correct here, and then we can turn on the grid already. Okay, we should have power here. Let's check quickly. Neutral, phase 1, 230, 230, 230. Between phases 1 and 2, 400 and the right. This is the correct phase order. So this should be all well. Let's turn on the inverter. Okay, we are showing again battery voltage, otherwise nothing, because the grid is still shut down. With this battery I do not have any communication. We have to use battery voltage as our primary information. What I want to do is set a maximum charge and discharge current of 80 amps or 4000 watts. That's enough for this battery. Let's end this video at this point. I will try to find a good setting here, and then in the next video we will talk about it, and hopefully all will just turn out perfectly as anticipated. So I hope you enjoyed this video. Thank you for watching. Please like, comment and subscribe to the channel, and I see you at the next one.